Welcome back, everybody. Happy whatever day of the week it is that you're watching this. We're going to move on to chapter 12 now. Chapter 12 deals with polynomials a little bit again, and we're going to look at synthetic division today, and the remainder theorem are the two things that we're going to look at today. So dividing polynomials is really the discussion for today. And I said, and the remainder theorem kind of as well, so evaluating polynomials. Eventually, we're going to work on factoring polynomials and those different types of things within this unit. So let's go ahead and get going on chapter 12, section 1. So synthetic division, briefly talk about knowing the meaning of the division logarithm. It's just going to confuse you. So we're going to use synthetic division to divide polynomials in the form, and then we're going to really work on using what they call the remainder theorem, and then decide whether the given number is a zero of a polynomial function. So really just going to worry about the last three objectives in today. There's the knowing. If you wanted to pause it and read through that quick, you can go ahead. Really our first objective then is going to be to use synthetic division to divide polynomials in the form x minus k. So we're going to use what we call synthetic division to divide this polynomial. Now you remember kind of long division from elementary school. Say you had something like 32 divided by 3. And you use long division to do this, and you said, okay, how many times does 3 go into 30, or 3 go into the first 3? So you could put a 1 here. And then you took a 1 times 3, and you multiplied 1 times 3, and you put it down there. And then you subtracted these two from each other, and you ended up with 0. You brought down the next number, and then you said, okay, how many times does 3 go into 2? Well, it doesn't. That gives me a 0 there. Again, you subtract them, you end up with 2. So then you had a remainder of 2. So a lot of times you would put 10 with a remainder of 2. Another way that you can write that, and a really more accurate way to write that, is 10 with a remainder of 2 with a numerator of 2 over 3. Where the 2 is your remainder and the 3 was your original divisor. So that was long division. We could use long division to do this problem right here. Problem with using long division to do this right here is it gets rather confusing, and it really gets to be quite a long process when you're doing that. Sorry, I had something going on over there. So there's a kind of a shorthand method for dividing polynomials. And what we're going to do when we divide polynomials is if you remember from Algebra 2, we kind of did this little box over here in the corner, and then we kind of spread out what our constants were, and that was called synthetic division. So inside of this little box, we're going to kind of look at this as, in a sense, it's x minus k. So we really put the opposite of what in there. So there's a 3 in there. So I'm going to put a negative 3 inside of the box because we're dividing in the form x minus k. So this would be the same thing as x minus negative 3. So my k value over there is negative 3, and it's the k value that's going to go in there. So mathematically, it's x minus k, and that's the k goes inside of that box. Real world wise, how we work wise, it's kind of the opposite of what you see in there. So if you see x plus 3, you're going to put a minus 3 in the box. If you see x minus 4, you're going to put a positive 4 in the box. It's kind of the opposite of what you see. And then we're going to continue down, and we're just now going to look at just the numbers, constants, in the numerator. So we've got a 2, we've got a 13, we've got a 30, and we got a 25. Now, one of the things that you have to check when you're doing synthetic division is you have to make sure, one, it's in standard form. So your exponents have to decrease from largest to smallest. And the other thing you have to make sure that happens is once you start, it has to decrease by 1 unit every time. And if that one's not in there, you need to put a 0 in there to hold its spot. So in this case, we go 3, 2, 1, none. So we're okay. I can just write the constants down that are in front of them. If, for example, we went 3, 2, none, I don't have the 1 in there, so I've got a constant, and then we'll get an example of that, I'm sure, here in just a second. So that's kind of our second part. The next thing we're going to do is we're going to draw a line. Now, step 1 is to drop that number straight down. So we're going to drop that 2 straight down. That's step 1. Step 2, we're going to take -3 times 2. The result of taking -3 times 2 is going to go right there. So -3 times 2 is just -6. Okay, so goes from below the line to above the line. So everything above the line, then you're just going to add together. So we're going to go 13 plus -6, or 13 minus 6, which is just 7. Okay, so now it's below the line. So if it's below the line, we're going to multiply whatever our k value was, we're going to multiply that together. And that gives us -21. Now we add those together. When we add those together, we get 9. Now we're going to multiply, because it's under the line, multiply to get -27. Add to get -2. Now this last one right here is going to be my remainder. So how do we write this out? Well, we started with x cubed. So since we started with x cubed, we are now going to make this as 2. We're going to decrease that exponent by 1. So this is going to be 2x squared. And then we're just going to continue down the line. Plus 7x plus 9. And we've got a remainder of 2. So what we're going to do with our remainder is we're going to put -2 over what our original divisor was, which is x plus 3. And this is dividing that polynomial using synthetic division. Okay. We're actually trying to figure out if it factors or not, or if it says we've got a 0 plugged in there, if -3 is actually a 0 and it's not. In this case, and we'll talk about that in some other lesson, but that's synthetic division and how we go about using synthetic division. Let's take a look and see what they did. They talked about the k value, they brought it down. They did essentially the same things we did. They ran out of room, and that's what we had for our solution as well. Okay, let's look at another one. So we've got 3a cubed minus 2a squared minus 2a plus 21, all divided by a minus 2. Okay, so we start with our box. And it's the opposite of what we see. So we see +2, so we're going to put a -2 there. First constant that we have is a 3, but notice it's 3a cubed. Now got to go a squared, and there's not an a squared in there. So I have to fill an a squared in there. So we're going to put a 0 there. Then we've got -2a, so it's -2. And then plus 21, so we're going to put 21 at the end. We draw a line. Bring the 3 straight down. -2 times 3. Above the line's -6. Add them. That's -6. -2 times -6 is 12. Add them together. You get 10. -2 times 10 is -20. Add them together. You get 1. Now we have to write our end result. We started with a cubed, so we're going to go 3a squared minus 6a plus 10. This last thing is our remainder, so we have a remainder of 1 over a plus 2. That's the result of synthetic division for this example. And you're done. Okay. Again, what we're finding out is that -2 isn't a 0. We would know if it's a 0 if we had a remainder of 0, but it's not. So a plus 2 is not a factor of this. Okay. Let's take a look what they did. Same thing we did. They do it a little differently, but again, same result that we had with this problem. Okay. So that's the synthetic division. Now we're still going to use synthetic division to use what we call the remainder theorem to evaluate a polynomial. We're still going to use synthetic division, so we're going to get a little bit more practice using that synthetic division. We're just going to do it in a little bit different question now. So the question now is going to be to evaluate, use what we call the remainder theorem to evaluate a polynomial. So if a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. So essentially what the remainder theorem is saying is that we can evaluate a function by dividing it using synthetic division for f of k. So for example, it says we're going to use synthetic division to find f of negative 2. Sorry. Okay. So we're going to use synthetic division to find f of negative 2. So we want to find the result of f of negative 2. Now, you found f of negative 2 before. We've done this quite a bit in here. We said if we have f of negative 2, what we could do is we could, anywhere we see an x in the function, we could replace it with negative 2. So we could go negative 2 cubed minus 5 times negative 2 squared plus 7 times negative 2 minus 3. We could find the result of that out, and if I don't have a calculator in my head, I had no idea what that's going to be, but we could solve that. What the remainder theorem says is it says that I can put the negative 2 inside of the box, and I can go with my synthetic division 1, 5, 7, and negative 3. And whatever the remainder of this is when I do this is going to be the same thing that would happen up there. So sometimes this math is actually a little bit easier and actually a little bit quicker because I bring down the 1. Negative 2 times 1 is negative 2. Add them together. That's negative 7. Negative 2 times negative 7 is positive 14. 14 times 7 is 21. Negative 2 times 21 is negative 42. So that gives me negative 45. So that tells me that the result of this, if I did it right, would be negative 45. That's what the remainder theorem does. Okay? Do we get the same solution? Probably. I mean, we'll see unless I mess the math up, which happens every once in a while. But synthetic division can make that a little bit easier, especially if you don't have that calculator. And sometimes, especially when you get that like that negative 2 cubed, you forget to put the negative 2 inside parentheses in a calculator. So sometimes actually synthetic division is the easier way to solve functions for a given input. Okay, so let's see what they did. Let's see if I got it right. Look at that, I got it right. So the answer for this would be negative 45. F of 2 equals negative 45. Okay. Let's look at another one of those. I'm going to go back here. Actually, we'll just do it right on this page. So let's do one more. Let's go f of x is equal to 3x cubed minus 4x squared plus 7. And we want to evaluate this at f of 4. Okay. So we're going to use synthetic division to evaluate this one at f of 4. And we're just doing one more example because I think you need one more example of that. Okay. So inside the box, when we're doing it this, we don't change it. So inside the box is going to be our 4. And then we go 3, 2. And notice I don't have an x, so I've got to put a 0 in there. And then we have to go 7. We're going to draw our line. Bring this number straight down. 4 times 3 is 12. Negative 4 plus 12 is 8. 4 times 8 is 32. 0 plus 32 is 32. 4 times 32 is 128. That's 135. That's my remainder. So that tells me f of 4 would be 135. Okay. So that's using the remainder theorem to evaluate a function. And whatever you're trying to evaluate, that's what goes inside the box. And then again, make sure that you go kind of in that downward direction when you're doing these. Okay. So then the last thing we're going to do, the last objective for today, is to determine whether a given number is a zero of a polynomial function. So that's the last thing that we're going to work on with this. And I talked about it a little bit briefly before, and we're going to use synthetic division again. And again, it's another kind of building block with synthetic division. And the way we're going to determine if it is a function or not is going to be if it ends up being zero. So a polynomial function is x squared, x cubed, x to the ninth. Those are what polynomial functions are. We're going to use synthetic division to decide whether 2 is a zero for this function. Too many buttons again. So we're going to use synthetic division to determine whether 2 is a zero of that function or not. So when we're determining if it's a function of 0 or not, it's kind of, we're not using synthetic division, but we're going to use synthetic division, but we're not going to change the sign. So we're just going to use 2 as our value inside of the box. And what we're going to be looking for when we're doing these is we're going to be looking for to see if we would get a remainder. And we want to look and see if that is a specific thing. And if that remainder is 0, then we know that 2 is a zero of this function. Okay, so if I do the synthetic division here, I get 3. 2 times 3 is 6. Negative 11 plus 6 is negative 5. That gives me negative 10. That gives me 7. That gives me 14. That gives me 0. So what this tells me is it tells me that 2 is a zero for this function. So if 2 is a zero, it essentially means that if I rewrote this, I could rewrite this as 3x squared minus 5x plus 7. And because 2 is a zero for this, a second factor of this would be x minus 2. Because it's a zero, and we've talked about zeros a lot in here of functions, these two things are really essentially the same thing. And remember, what makes that 0, 0? Could we factor that first thing? We could. But today you're just going to be determining if it's a zero kind of or not. Okay, so if you look at their explanation, they ended up with 0. The remainder is 0. Since the remainder is 0, 2 is a zero of the function. Okay, and we don't have to take that kind of any further than that piece of it. Okay, so let's look at one more example of something like that. Let's go with f of x is equal to 3x to the 4th minus 4x to the 3rd minus 3x squared minus 2. And I want to know whether 2 is a zero of that function or not. Okay, so we're going to use synthetic division to do this. Okay, so because we're trying to determine if it's a zero or not, I'm going to put a 2 there. Don't have to change the sign, only have to change the sign if they give you a factor. So I start with a 3, then I go a negative 4, negative 3. I don't have an x in there, so I have to put a 0. Make sure you always check for that. Okay. Bring down the 3. That gives me a 6. That gives me a 2. That gives me a 4. That gives me a 1. That gives me a 2. That gives me a 2. That gives me a 4. That gives me a remainder of 2, which is not 0. So 2 is not a 0 for this one. So this would be a big old fat no. It is not a 0 for that function. Okay? So 3 things today. Synthetic division. Make sure you change the sign when you're using synthetic division. The remainder theorem is going to help you evaluate functions You can use synthetic division to do that. And then the last one is to determine if it is a 0 or not. And with the last two, remember, you don't have to change the sign for the number that kind of goes over in that box on the left-hand side. Multiply this way, add this way. Multiply, add till you get to your remainder. There's lesson 12.1. On to 12.2 for the next lesson. Have a great day, everybody. Stay safe out there.